we can start about the second topic. About the layer 2. Maybe first days, I think topic someone maybe think is too easy for you. So if you are more interested about some difficult one, maybe we can begin on the second one. For the second day. The next part is about the layer 2 switch principle. According to the introduction of the beginning, we say if two computers can directly connect with each other, we give the IP address, right? And then we can use some like FTP to transfer the file successfully. But if we have long distance, maybe located in different floor or maybe in different building, if we use a cable, there's some limitation because about the network cable, the longest distance is 100 meters. So in this scenario, we will have a new devices we call it layer 2 switch. And we can use the switch to connect with each other and make the distance longer. So about the switch, the most protocol we use is Ethernet. Attention about the Ethernet is the data link layer protocol. And this is widely used in the LAN network. LAN is local area network. So it's very necessary to know the function of the layer 2 switch and what's the principle. Now the configuration of layer 2 switch is very easy. I think you only give the power and they can work normally. But you have to know the principle because maybe in the future when you do the troubleshooting, you can, according to the principle, to do that. Okay. The first one, let's see the background. Why we use the switch? In the early network, the devices only can provide a single point to communicate with each other. That means if two computers, now I use a cable to connect with you, and the third one you have to wait. After the cable connects to you, then we can send the other message, something like this. So if we want to improve the transmission efficiency, for example, lots of people can communicate within the same time, we need a multi-point communication mechanism. At the beginning, we also, before the switch, we also have another devices like the hub, right? Do you see the devices of hub? The hub also can have multiple points, multiple interface, and lots of devices can connect with the hub. But at the same time, only one terminal can send out the message. And the second one wants to send out, they have to wait. So this is the limit of the hub. And now we will use a switch to connect with each other. And about the switch, we will divide the different interface to become different collision. This one is very important. We see before the switch, we use a hub to connect with each other, but all the terminals within the same collision. That means in the one time, only one user can send out the message. Like the training now, in the same time, if I am talking the presentation, you have to wait. If I am stopped, you can start. Otherwise, we will conflict. But if we use a switch to connect with each other, the switch can divide different interface into different collision. And the different interface, we can send out the message at the same time. And then the switch for the traffic according to one table. This table we call is MAC address table. So this is the advantage of the switch. We can divide different interface into different collision, but hub cannot. Okay. Also, maybe hub also have lots of interface to connect with each other, like a start port, but the principle is the bus station. So this is the switch. And about the Ethernet switch, this is the page of rich devices. We have lots of interface. Of course, the interface type and the interface and the number of interface depends on which detailed device you use. Like these devices, the left we have the lighter, right? And maybe it's a gray, maybe it's yellow, maybe it's red. That means they have different problem. If the green, the device is okay to working. And the first interface is a console interface. We have to use a console line to connect with this interface. Then you can use some tool to give the configuration of the device. And this part for you can see this is a service interface. You can connect with the network cable, and then the other side you can connect with the terminal, or maybe you can connect with some router or switch to connect with the other. And also maybe some devices have the fiber interface. This interface can provide higher speed, something like this. And also this is a page, and the other front page plan, we can have the interface to connect with the power. And this is a switch picture. And about the switch, receive the message from the other devices. We will force the traffic out according to the MAC address table. So this also is very important for the switch. I receive the information, discard it, or forward it, or flood it, depends on your MAC address table. So this is a key point on this topic we have to know. The working principle of layer 2 switch, we have two things to do. The first, you have to make your MAC address table. This process we call is learning record to make your MAC address bigger. And how to add your MAC address? First, you have to know in your MAC address what's the information we will add. What is MAC address? And connect with the switch. When we receive the message, pay attention. In the message, we will do the encapsulation. And if you want to know the encapsulation detail, maybe you can focus on the YouTube and see the detail principle. In the message, we will add the source MAC address and add the destination MAC address to let the switch know where the message is from and what's the destination. And in the MAC address, we will record the source MAC address and the receiving port. Pay attention. These two parts will be added into your MAC address to build your MAC address table bigger. And then, this is the first thing switch have to do. The second one, the main function of the switch is help us to forward the traffic. So, we have to enter the MAC address table to check. Then, according to your MAC address table, then forward the traffic into the destination. So this is the second step of the table looking up and forward. And later I will give you some example to explain these two processes. About the forwarding, if the MAC address exists in the MAC address table, the switch will forward the frame based on the special port. For example, now if this one indicates 5 ports of the switch, I receive from the first port, and then I will check the MAC address table. Then the MAC address table will show you have to forward, and the forward interface is the fourth one. So only will be sent on this interface. The second action is flooding. Flooding means the destination not exists on the MAC address, and then the switch will help you flood to all the interfaces. Pay attention, except the receiving interface. So if I receive the message from the first one, what's the action of the flooding? All the interface out will be sent the message. So this is a process of forwarding, of the flooding. Pay attention, if the destination exists in your network, we do the flooding. Finally, the message will be sent to the destination. But maybe your destination only located on the second port. The other interface send the message out will waste the bandwidth of the link or the other devices. So we hope if we can unicast forwarding, we will not use the flooding. Okay, so this is our hope. And the third action is discarding. If the destination MAC address of the date is a MAC address to the receiving port. That means I check your destination MAC address and find the connection interface is same with the receiving port. So in this scenario, I will directly discard the packets. I will not forward to the same interface again to avoid the loop. So in this scenario, if I receive, I will not forward again. So these are three actions we will do in our network. And later, let's see the first one. How to forward the traffic? What's the action we will use to forwarding or flag or discarding? Depends on your MAC address table. So the MAC address table is very important. And when the switch is just started, maybe it's the first time to get the power, there is no entry in the MAC address table. And in the table, the key parameters we have to know is the MAC address and the port. For example, like this topology, there is a switch, and we have three interfaces. It's a 1, 2, and 3. And later, if PC1 send out the message, for example, the source MAC address is MAC address 1, but the destination MAC address is special. OF means this is a broadcast packet. So this is special one. About the switch, what's the action will take? The first one, when layer 2 switch receives a message from PC1, the first things we have to do is learning, right? Learning means I will record the source MAC address and the receiving interface. So the MAC address and the first port will be added into the MAC address table. Then I will do the forward. About the forward, we will take the destination MAC address to track your MAC address table. But this destination MAC address is special, OF. OF means you have to block the message. So this message will be forwarded from 2 and 3. Someone say why PC1 will send out the broadcast message? Because like the ARP packet, the first packet is broadcast packet. Okay, so this is the first one, how to build the MAC address table. And then if PC2 and PC3 responds to the date frame, right? 2 and 3 will give a reply, hello, what's my information? Maybe it's ARP reply, maybe the other message. And in this frame, also will carry the source MAC address and the destination MAC address. But the source MAC address is PC2 and PC3. The destination MAC address is PC1. So when switch 2 receives this information, the first process is learning. So I will add the source MAC address and the interface into the table to connect with the port 1 and port 2 and port 3. Then to forward the traffic. If the destination is PC1, this message only will be sent to PC1. So this is the learning, okay? And in this process, how to maintain the MAC address table? If the switch port is down, for example, the cable is deleted, or maybe PC doesn't send any packets within 5 minutes, then the switch will delete the entry automatically. So this is a maintenance. So if one link is broken, this MAC address will be deleted. Pay attention about layer 2 switch. We have some limitation. Depends on the depends on the performance of the switch. Maybe some switches only can receive 1,000 entries of the MAC address, but the other one can record more entries. If your MAC address table is bigger, I will only do the forward as soon as possible. So this one is a little different. And after we get the full MAC address table, then let's see the process how to forward the traffic. If PC1 sends a unique cast frame to PC2, let's see the process. PC1 encapsulates the source MAC address is PC1, the destination MAC address is PC2. When L2 switch receives this message, I will send the message according to the destination. So finally, we will find the destination connect with port 2, and the message will be sent to port PC2. So this is a unicast forwarding. Okay, the other interface we will not flag. And on the link of port 3, there is no frame it will be wasted. And about the flooding, although maybe your MAC address table learning the entry as soon as much as possible, but some scenario will flooding the metric or the frame. And what's the scenario? First, if I receive the broadcast address, or maybe it's multicast address, or maybe it's unknown unicast address. Unknown unicast address means this destination address not located into the MAC address table, and this message will be flooding. Flooding means send out the message from all ports except the receiving interface. So this is a flooding process. Okay, match to interface and send out. So this is a flooding. So that's why we say if we use a layer 2 switch, we can divide the collision domain. Different interface, different terminal, we can send out the message at the same time. But they cannot lead the broadcast domain because layer 2 switch will directly forward the broadcast message out. So how to limit the broadcast message? We can use a layer 3 or maybe a router to do this function. For example, like this one, we can use layer 3 or router to divide a broadcast domain. One layer 3 interface is one broadcast domain, and one router also is broadcast domain. So this is a solution. And if we use a router or layer 3 switch to divide the broadcast domain, it's very expensive, right? And we also have another solution like VLAN. That's why VLAN is very important in our network. It's used to make the broadcast domain smaller. So this is a part of the switch. It's very easy for us because you don't need to add any command. When you give the power, the switch will learn the MAC address table automatically. And then according to the MAC address table forwarding out automatically. You don't need to give any configuration. You only have to decide if this switch performance is enough for your network. It's okay. Yes. So about this part, the first practice question is, an layer 2 Ethernet switch generates a MAC address enter based on which parameters? Can you give me some answer? Source MAC address. It's very easy, right? The correct answer is A. We will learn the MAC address according to the source MAC address. Yes. The second one, once a MAC address entry is generated on the switch, it will be cleared unless it is manually deleted. So this sentence is true or false. B, yes, it's false, right? When the print time is off, or maybe the interface is broken, this MAC address will be deleted automatically. So the answer is B. And the second one, no C. The second one, in the following topology, all hosts can communicate with each other. In this case, there are how many broadcast domains and how many collision domains on the network. How many broadcast domains? Yes, it's 3, And 1, 2, 3, 4, 5. It's 3 broadcast domain and 5 collision. It's easy, right? Because we only use the layer 3 router to limit the broadcast domain. So if you want to make the layer 2 broadcast domain smaller, in these places, you have to use the VLAN technology. And the collision is layer 2 or layer 3, one interface or one collision domain, but about the left one, there is a hub. And about the hub cannot divide the collision domain. So here is one collision domain, 2, 3, 4, 5. Different collision domains, they can communicate with each other at the same time. And this one is more important for you. For example, now here is a switch, and the switch already learns the MAC address table, and here is a MAC address, and here is a port. So if the switch receives the following message, what's the action will take? The first one, if I receive the message from 01, the source MAC is 00FF, and the destination MAC is 111. What's the result? What's the action we will take? According to the MAC address table. Discard, forward, or flooding. The first one, I already see some answer, right? The special of the first is we discard. Yes, this is the correct answer. The first one, we will add the MAC address FFF and connect with the first interface. The second one, I will check the destination MAC address 001 to the MAC address table. And according to the table, I have to send out to the first interface. It's same with the receiving interface. So this message I will directly discard. Maybe in the first interface, there is a hub, right? So this is option B. The second one, if we receive the message, the port name from the second interface, the source MAC address is F, and the destination MAC address is 1. So what's the action? What's the action of the second one? C, forward. Yes, we have to forward it, right? Because I take the destination 1 to match the MAC address table, and now we found the destination connect with the first interface. And this interface is different with the receiving interface. So I will directly forward it and forward to port 1. And what about the third question? Receiving message from 01. I will do the flag, right? Because the destination is not exist on our table. So I will directly discard it. Really? App keeps crashing on PC and browser without show remote screen. Ready? I will check the problem later with our team. So now you can see my screen. So this answer, this one is easy for you, right? About the switch. So about this part, we talk about the principle of the switch. The main process we have to know is the first one, learning MAC address table. And the learning process is add the source MAC address and combine with the receiving interface and add them into the MAC address table. Then we will follow the traffic according to the MAC address table. 3 actions. Only forwarding if the destination MAC address exists on our table and the connecting interface is different with the receiving interface. The second one, if the destination MAC address is not located on the switch and the switch will flood. So this one is very important with router. Router for the traffic also will check the table. This table we call is IP routing table. But about the router, if we cannot match the routing information we will discard, we will not flood it. So this one is different. The third one, we will maybe discard the message. If we use the destination MAC address and check with the MAC address table, find the out interface is same with the receiving interface. In this scenario, we will directly discard. So this one is the main point of the switch. And later, layer 2 switch can only isolate the collision domain, but cannot isolate the broadcast domain. That means if we send out the broadcast message in layer 2 switch, all the scenario, all the link, all the devices will receive this broadcast message. So if you want to limit this range, maybe you can use layer 3 ports, like the layer 3 switch, or maybe router. But this one is very expensive. So we hope we can have a technology to solve this problem. And this technology we call is VLAN. So the next part, we will talk about the VLAN.